Oh, hello. Welcome, everyone. I guess we're live. This is Shirley of Angel Hack, the organizing team of the Hello Future Hackathon. And we're excited to welcome you once again to our imagine that, seventh and the last workshop of the Hedera Apex Hackathon, which runs from 17th February until 23rd of March. So we're now at the end of the week three of the hacking period, and this is one of the back-to-back workshop weeks. Keep up the great work, everyone, and let's focus on creating high quality projects that can catch the attention of Hedera and its ecosystem partners. Okay, so with a prize pool of 250,000 and such a strong ecosystem support, it's no wonder that the Apex Hackathon became one of the most anticipated Hedera hackathons of 2026. And we're just so excited to see the amazing projects you'll all create. But it's not just about the prizes. This hackathon powered by an incredible lineup of partners, including AWS, Neuron, Hashgraph Online, Bonzo, and Hiero, all bringing their expertise and support to help you build something truly impactful. Now, without further ado, I'm excited to introduce today's speaker and mentor, Kiran from Hashgraph. Kiran's focus is on DeFi, tokenization, and EVM. So his workshop entitled Deploying Smart Contract with Native On-Chain Automation tackles EVM. Okay, so please feel free to ask questions during the session by typing in the live chat and we'll address them at the end if time permits. If your question comes later, that's completely fine. Please fill out the form that I'm going to share right now. Okay, I've just shared it. Okay, and then once that is done, I will pass the question to Kiran. Once Kiran answers, I will email you. So if you have received any email from me answering questions we received from the EMA form, yes, that's really happening, and I'll do that once again. I'm sharing the link now, so please click on that. And then, of course, the best thing, how can you connect with Kiran is join Hedera's Discord and go to the dev support channel, start chatting with your mentor and the organizing team. Okay, now I'll hand things over to Kiran. Kiran, the stage is yours. Take it away.
Thank you, Charlene. Hi, everyone. I'm Kiran. I'm a developer advocate at Hashgraph. I've been just a little bit of a background for myself. I've been software engineer for the last decade or so. I joined Hashgraph about a year ago, but I have been in the Hedera community for a while now, since the early days, 2018, 2019. I've been in the blockchain industry since 2017. I've worn multiple hats over the years, from a software engineer to DevOps engineer to, I even worked as a developer relations engineer for another company. But yeah, today I am going to demonstrate you on a lot of the cool things that you can do on Hedera that is just not possible on other EVM chains. So just as a background, what we're going to be doing is, by the end of the workshop, we'll have a smart contract that's deployed on Hedera testnet that's going to schedule its own future execution. Now, that's a really cool thing, I believe, because on a lot of other EVM chains, what happens is, you have to use some off-chain infrastructure, some kind of bot server or keepers or gelato network or whatever it is, right? You have to use that to do any kind of schedule any kind of on-chain future transactions, right? But on Hedera, it's entirely possible. The network itself handles everything. So we're going to do that. On the workshop itself, what we're going to do is we're going to build an ERC20 token that is going to automatically airdrop the tokens. It's going to mint the token and then airdrop the tokens to random recipients on a schedule. Let's say every 30 seconds, it's going to choose a random recipient and airdrop it automatically without us having to manually trigger the action. And we're going to see it in action on the Explorer itself. So without further ado, let's go ahead and get started. So first things first, let's see what's on the agenda today. So I talked about the way that Hedera has with its ability to schedule future transactions. We're going to understand what that, what's the reason that's possible, right? Why is it that Hedera has it, but other EVM chains don't have it? So we're going to, that goes a little bit into a recent HIP that was implemented on the mainnet, HIP 1215 more specifically. Feel free to look that up later, but I'm going to give a brief primer on it and what it is. We're going to deploy hands-on, build and deploy. We're going to interact with it. We're going to see it on the Hashcan Explorer. Hopefully, you'll also participate with me because there is, as part of the demo, what I'm going to have is I'm going to share the contract address in a little bit after I deploy, and then you guys should feel free to interact with it directly from Hashcan and register yourself, so we can all participate in this little exercise. All right. So before I even go to the demo, right, I want to make everything clear on what exactly makes this possible on something like Hedera. So what I'm going to show is I have a, let's see here. Okay. Okay, there it is. Okay, so I want to show you guys the contract that I had already deployed before, and we're going to see what actually was happening, right? So here, if we check it out, we'll just check it out quickly. I'm not going to go too much into it because we have the demo in a little bit. But all this is doing is calling this start airdrop. What this is doing in the background, it's starting the scheduled transaction. So what's happening is every 30 seconds, we are executing. We're telling the network, hey, wake me up in 30 seconds, and then execute this particular function every 30 seconds, right? So that's what we're telling here on the contract call itself. All we're doing is, it's saying max drops is 10, so we're gonna execute this this function up to 10 times, and then it's going to stop automatically. Because if you don't, you can make it so that you can have the contract call itself every 30 seconds, every minute, whatever it is, forever and ever. But you're gonna run out of HBAR on your contract, because the way that it's going to be paid, as far as the gas transaction fees, the contract itself is going to use its own balance to execute the future transaction. So if your contract has a lot of HBAR and you have this infinite loop of this cron job that's running every 30 seconds, chances are you're going to run out of the money pretty quickly. So I have set this limit here on as far as how many times we want to execute this, but you can have this be executed forever and ever. All right, so let's go ahead and check it out. So that's the first transaction, right? That schedule itself, and then this is the second transaction. This is the main thing that makes everything possible. So, as we can see here, you see this was executed 9:40:39, and then the next one we see 9:41:07. Next one I see 9:41:36. Basically every 30 seconds. I can check it out, right? I can go to any of these and I can see the exact same thing. We see here. We go to trace, we'll see a little bit here. So this is our contract address. We can see here that on a normal transaction, usually the from and the to are usually different, right? Because you have, as a user, you would be calling a contract, and then on the from, you would have your own address, and then on the to, you'd have the contract address that you're executing. But here we see it's the exact same smart contract address, because it's that power behind how the scheduled transactions work. So you see here the contract address for from is the same, to is the same. It's literally saying, hey, hello scheduled airdrop contract is calling itself, and then it's calling this function execute airdrop with whatever amount of gas that we set. And then at the end, what it's doing, right here, actually, yeah. So at the end, what happens is it calls it, it executes it, and then the last thing that it does is it schedules the next call, let's say 30 seconds from now, whatever I have set here. I think it's 30 seconds. So it keeps doing that again and again and again, and then up to 10 times. And then finally, when it's 10, it finally stops. So that's the demo. We're going to do this demo in a little bit here. But let me hop on back over to my slide, so we can talk about this, like what it makes it possible, right? So there's no bot running on my laptop. There's no keeper service, no Chainlink automation, no Gelato network. The contract literally is scheduling its own next execution, and Hedera's consensus layer is running it. All right, let's go ahead and go to the next slide. All right, so the next slide, we talk about what is actually the problem, right? There's this problem, there's this automation problem with smart contracts that happens on every EVM chain. So smart contracts are smart the way that a calculator is smart. It knows the answer to everything, but it'll just sit in your drawer for a decade unless you poke at it. And that's basically how the smart contracts of today work in most of the chains. So you can think of a smart contract like a vending machine that's just bolted to the floor. It has all this logic inside, and it knows exactly what to do, but it can't do anything until someone walks up and then pushes a button, literally, which means it executing a transaction. If we think about all the real life use cases, right? You may have a DeFi vault that needs to rebalance on a daily basis, right? Every single day you want to rebalance your vault, and then what happens today? Someone has to manually call a function like rebalance every single day manually. Someone has to do it. And then what if you're talking about the recurring payments that need to go out? Like someone has to trigger that function again, that distribute function. The contract just sits there waiting for someone to call. And the gas model, makes this kind of inescapable, because what happens is every computation, as we know, on a smart contract, it costs gas, right? And gas has to come from an externally owned account from a user. A contract literally cannot initiate its own execution. That's the most basic definition of a smart contract. It's not a bug. It's by design, right? It's a fundamental constraint of the EVM itself. So the question becomes, well, who pushes the button? And the way that something like Ethereum and many other chains solve it today is the answer to who pushes the button is you hire someone to push it for you. So it may be some automations, and Gelato network, Open Zeppelin Defender, or your own custom bot server that you have running somewhere. And you have to pray that it keeps running, right? It has it is well maintained. It doesn't stop, because as soon as it stops, well, then your smart contract also doesn't get executed, whatever function that you want to call regularly. So one thing to note is these services work, right? They have been working for the longest time, and there's thousands of protocols depending on these off-chain infrastructure. But we have to think about we have to be realistic here. Like, we have to think about what we're doing. We're basically, we built this beautiful decentralized smart contract, and then you're handing the keys to a centralized service to keep it alive, just to keep it alive. Because if your bot, whatever it is, it goes down, your automated strategy, that rebalancing, it just stops. You're paying someone a premium on top of the gas that you're already paying to keep maintaining, to keep calling this trigger, right? The current decentralized solution is basically like you're hiring a butler to stand right next to your contract and then poke at it with a stick every hour. And that's basically what it is. And the butler wants a fee and a tip. And sometimes he just doesn't show up. But what if wouldn't it be better if the vending machine, the smart contract, just did everything itself? And so that's where Hedera's scheduled service comes into play. Right, Hedera has something no other chain has, or most of the other chains don't have, is the Hedera scheduled service. It's not a smart contract someone deployed on top of the network. It's a native protocol level service, and it has been there for a while. It's basically a precompiled contract that's baked into the node software at a particular address. Like it's the address you see here on the screen is 0x16b. You schedule a transaction, Hedera stores it, and then at the time that you specify it, the consensus nodes themselves, they execute it. There's no middleman. It cannot be upgraded by users. There's no solidity level bugs because it's the protocol itself doing everything. It runs at native speed, right? What's interesting about the history of the Hedera scheduled service is it was originally built for multi-signature transactions, where you schedule a transaction, collect signatures from different parties over time, and then it executes once you have enough signatures. And what HIP 1215 did was it expanded that whole service to allow smart contracts to schedule calls to other contracts. Now that is a very genius idea, because that means it opens up this interesting use case where the smart contract itself, the smart contract can call itself at a future time, right? All right, so HIP 1215, let's talk a little bit about it. This is the secret sauce, right? Before, as I talked about, only external SDKs, APIs could schedule transactions, future transactions on Hedera. It worked perfectly fine. But after 1215, a smart contract can call the Hedera schedule service system contract, and then it can schedule a future call to itself or to any other contract. It doesn't matter. And then what HIP 1215 did is it turned Hedera from a ledger into a living organism, right? If we think about it. That's the very difference between something like a library and a factory. Think about what that means, right? A smart contract can schedule its own next execution. And when that next execution runs, it can schedule a next one. And then you get this self-perpetuating loop, an on-chain cron job with zero off-chain infrastructure. The consensus layer itself, the network, executes your scheduled calls, right? There's no bot, there's no keeper, no off-chain infrastructure. It's the protocol doing everything for you. All right, we're gonna talk a little bit about what is the actual function. It's very, I don't want anyone to get overwhelmed about the service, because under the hood, it's a very simple smart contract call. It's a precompiled call, but let's understand this function that makes everything work, right? So it lives on the Hedera scheduled service system contract at the address that I told about earlier, 0x16b. And then this slide, it basically breaks down all the parameters that it takes. So we have the two most important one that you mostly care about is the to and the expiry second. So to is which contract you're calling. In our case, we're going to point it right back at ourselves, which is the whole magic behind self-scheduling. And then the expiry second is when it should execute as a Unix timestamp, right? So you could use something like block.timestamp plus 30 or something like that, which means run this 30 seconds from now. Or you can even schedule it up to I believe around 62 days in the future, which is pretty amazing, right? Being able to have this cron job running, let's say once a month or once every 2 months. That is an amazing feeling, right? So there's also other parameters like gas limit and value. They're the ones that handle the resources part of it. So on our smart contract, we're going to allocate 2 million gas to be safe. Again, with a recent update to Hedera, it really previously the network would take at least minimum of 80% of the gas limit that you pass. So you had to be really careful the limit that you pass, the amount of gas that you're willing to spend. But pretty recently, and it's already enabled on mainnet, it happened about a month ago. But with a new capability, what that means is the Hedera network, it will not take that 80%, the minimum 80%. What happens is if you were to pass in 2 million gas, if you were to pass in like 2 million gas, let's say, and then it only costs like 1 million, it's only going to spend that 1 million and ignore the rest that did not get used. Previously, it would have taken 80% of 2 million, whatever that number is, right? So it'll be what, 1.6 million, I guess, minimum. So it's a really cool feature, and so just to be safe, we're gonna pass 2 million gas. That should be fine. And then there's the call data. This is the ABI encoded function call. This is literally the function signature and the arguments that Hedera will be executing at the time that we define, right? So when I say the contract calls itself, this is what I mean. We are gonna encode our function, execute airdrop. That's the function name. We're gonna look into the code a little bit. We're gonna encode that into bytes and then hand it off to the scheduler. And then it's going to return the response code, success, whether it got scheduled correctly or not. But that's the general idea behind this function. All right, so this is what we're building today. Picture a single Solidity contract that mints its own token, lets anyone register for airdrops, and then picks random winners using Hedera's built-in randomness. That's the PRNG precompile that we're going to be using. And then the kicker is, it schedules its next execution automatically. So all in one line, about 150 lines in Solidity. You could get away with less because this is a very simple ERC20 smart contract. But I've actually written a very simple hello world self-scheduler smart contract in less than 50 lines of code. So and the Hedera scheduled service capability on smart contract level, that is what makes it possible. All right, so we're gonna go to the actual architecture, how it actually works under the hood. Let me walk you through the whole life cycle, right? And I think it's gonna, once you understand how the whole thing works under the hood, when you look at the code, you're gonna be able to understand exactly what's going on when you look at the different functions. So what's this is the mental model. So this is how you can picture it, the way that it works, right? So the owner, which is me in today's case, we're gonna kick things up by calling start airdrop function, and then the contract immediately calls the schedule service at that 0x16b address, and then it says, hey, call my execute airdrop function n seconds or 30 seconds from now, right? Hedera stores that request and the contract goes back to sleep. It's done for now. And then when the scheduled time arrives, the Hedera network wakes it up, wakes up the smart contract, and then calls execute airdrop. Nobody triggers it, right? The protocol itself does it. And then inside that function, we hit that random number generator precompile. It gets a random number, picks a recipient, and then mints the tokens to them. And then here's where it gets interesting. At the very end of this execute airdrop function, the contract schedules its next execution. The loop is pretty much self-sustaining at that point. You execute, schedule, sleep, wake up, execute, schedule, sleep, wake up, until we hit the max drops, or we decide to pull the plug by calling stop airdrop or something like that. All right, that's the whole architecture. Some of the prerequisites, while I'm talking about these, I hope you guys have had a chance to do this, but feel free to do it at the same time right now. And the QR code that I have at the top on the right, I think it's hidden, but it's basically the GitHub link, Hedera dev tutorial hello schedule airdrop. You can basically clone that repository locally, because we're going to try to deploy this. And again, you don't have to do it with me, but feel free to play along. But at least I would suggest have your Hashcan Explorer open so you can check out all the transactions that are happening. And I'll put in the contract address in a little bit after we deploy it. All right, so this is all we need to do. We're gonna do it. So I'm just gonna skip through. I hope you have some HBAR, but if not, again, totally fine to just watch me do it. All right, so one last thing before I want to jump in. Again, like this is the I just want to make sure that everyone understands the code, so we see. All right, so what we're doing is we have this Open Zeppelin's ERC20 contract, right? It gives us that standard token functionality with mint, transfer, balance tracking, all of it. We're going to use ownable because we only want the owner to be able to execute certain functions. We don't want random people to start executing the airdrop. And then we have, this is the most important part. We have Hiero smart contracts. And by the way, the system contracts previously used to be located at Hashgraph, Hashgraph's system contracts, but they are soon moving to this new repository. And again, that's why we're going to be using this today, and you should also use this going forward. But yeah, the import path is Hiero Ledger, Hiero contracts. That's the GitHub repository name. Again, we're going to see this in action in a little bit. All right. So let's see a little bit about the code. As you can see, we have this state. It's organized into this config struct. What we're doing is we're basically bundling the campaign settings, our airdrop campaign, into a struct instead of individual state variables. It means that when a campaign ends, you can basically reset everything by just assigning a new struct, right? That's why we have this. It's just to keep everything clean and simple and atomic. So inside, we're going to have tokens per drop, interval in seconds, max drops, 0 means unlimited, and the counter, active flag, and everything like that. And then we have the register for airdrop. It's very simple. We check that they're not already part of the recipient list. And we're going to add them to the array and then emit an event. There's no approval needed, no whitelist, no minimum balance. In production, you probably want to gate this, maybe require an NFT or a minimum token balance or whatever it is that you want to do. But for the workshop itself, I think lower friction means more participants and then a better demo. So also it'll be easier for me to do it this way. So, all right. So this is the main slide that talks about starting the airdrop, the self-scheduling loop, how it works under the hood. So this is the heart of the contract, right? We have two functions. Start airdrop, I talked about earlier, only the owner can call this. It takes the parameters, tokens, interval, max drops, blah, blah, blah. And it checks there's no active campaign running and at least one recipient registered. And then it sets up the config. And then the execute airdrop, this is the function that the Hedera network calls. Nobody calls this manually. We talked about that. Notice that, one thing is the caller isn't the owner, it's the protocol itself. And then inside it picks a random recipient using Hedera's random number generator precompile. It mints the tokens to them, it increments the counter, and then it emits an event. So those are the airdrop executed events that we're going to see on Hashcan in a little bit. All right. And then schedule with capacity check. It basically, if we haven't hit the max drops, it basically calls schedule with capacity check again to schedule the next execute airdrop. And then the loop continues again and again and again. So execute, schedule next, execute, schedule next, blah, blah, blah. It's basically, it's the closest thing you're going to get to set it and forget it kind of deal. One thing to keep in mind is, though, execute airdrop, if it reverts for any reason, while the future schedule call is calling it, the next one does not get scheduled automatically and the loop just breaks. That's actually a safety feature for yourself. Because all you have to do is fix the issue, whether you're low on HBAR, on the contract, whatever it is, and then you just call the start airdrop function again, and then it just restarts the whole thing. All right. And then this is the random number generator. This is another precompile that Hedera has. This just gives you out of the box. This is how we're gonna pick a random recipient. It's like calling a guy across the town to roll a dice for you, waiting for a callback, and then paying $3 to $5. Again, that's just a random number dollar amount that I have here for the privilege. So this is actually a built-in random number generator at the protocol level. So the get pseudo random seed actually returns this byte 32 type, and then the randomness itself, if you're curious about, it comes from the Hedera's consensus process itself. It's a hash derived from the transactions running hash and then the consensus timestamp. So it is quite unpredictable before the consensus even happens, but it is deterministic after, and that's why it's for regular use case you could totally use this. For production, I would still have some more gated feature. But this is protocol level randomness. We're not using block.timestamp, which again you could totally, but yeah. All right, and then let's see, before we jump in, almost there. One more slide, and then we're gonna jump into the demo. Here's something clever that you could, that again we're gonna see this, that makes this production ready, right? What if the time slot that you want in the future is already full? Because what happens is, it's not free to store these scheduled transactions, right? Because you can't have millions of them executed at the same time. So there should be enough. There should be empty slots, and then only then, whenever the way that the scheduled transactions work is, let's say I set it to execute 10 minutes from now. 10 minutes from now, the network sees, okay, this has to be executed, but then it just tries to do that on a case by case basis, where what that means is sometimes, your scheduled contract, it may not be executed at exactly 10 minutes from now. What it means is After the 10 minutes has passed, the network will try to execute it. If it can't, it will move on to the next time, and then it will try to execute it there. So, there may even sometimes be a case where the network is really busy, and if you just try to schedule something in the future, it may not get executed on time that you want. Right. So in order, again, this is not 100% foolproof, but there is a pattern that you can use. It's called, we have this has scheduled capacity. It's basically a function that checks if a specific time slot can accept another scheduled call. This is very unique to Hedera. So the find available second that you see here, it basically first tries your exact desired time, 10 seconds, 30 seconds. If it's available, great, we can use it, right? But if it's not, then what we're going to do is we have this exponential backoff with random jitter pattern. So what it does, and that's a mouthful, but let me try to explain that. It basically probes at the interval, so 1 second out, and then it tries to find the slot. Okay, no, not available. 2 second out, it doesn't find the next available slot, and then 4 seconds, and then 8 seconds, 16 seconds. It just does that every time until until you can find that empty slot, and then it schedules your call during that time. So it's a very unique way, exponential backoff. It's my own personal strategy for responding to emails. If I don't reply in an hour, I'll reply in 2 and then 4. Same thing, right? You're having the same logic here. All right, now finally, let's go over to our let me just, okay, I have this open. All right, that should be pretty easy. All right, so let me just clear this up. Terminal. All right, so by the way, feel free to follow along the guide. It's already in the GitHub repository here under docs, guide.md. But what we're going to do is we're going to first check out the contract, right? Let me just get out of this. So we saw here earlier, Solidity, we're importing OpenZeppelin, ownable from OpenZeppelin again. Hedera schedule service is from Hiero system contracts. The way to install is actually, let's see, Hiero. It's Hiero ledger / Hiero contracts. That's what you see here on the foundry.toml file. But anyways, this is the path. So all we're doing is we're inheriting from ERC20, ownable, and Hedera scheduled service. We're setting the gas limit to 2 million. Again, depending on your use case, your function, you may have to have your own gas limit here. Max probes, this is more for finding the empty slot, like how many times are we going to back up and then try to find the next available slot. We talked about config. It stores the amount, interval, max drops, all of those good things. We're storing the recipients for the airdrops. We're going to have a variable to check if someone is already registered. We have a whole bunch of events that we're going to fire up. We're going to see this. And then the constructor, all it takes is the name of the token, symbol of the token, and then the initial supply. So nothing too fancy, still, regular things that you were used to. And then register for airdrop. This is the function that anyone can call using their account. It's going to check whether the recipient is already registered. If not, then it's going to add it. And then this is the function that I talked about earlier, right? We have start airdrop with the amount that we pass in, the interval, 30 seconds, 1 minute, whatever, max drops, how many airdrops that we want to do. And then the call data message is the actual signature here. All right, sorry, that's the message that we emit every time. Execute airdrop. You see here that when we call start airdrop, okay, it finds the target time, blah blah blah, and then it calls this function here as schedule with capacity. So let's check it out what that is. So we're finding the next available second. Again, we went over this function, but it's a very unique pattern, exponential backoff. We're using the random number generator that Hedera provides to find the random seed, and then we're going to try to find the next available slot by using this has schedule capacity precompile. And then it finds the actual time, and then it schedules, right? And then we see over schedule. All the scheduler does is it encodes that our function, right? Execute airdrop is our function. It encodes it, and then it tries to schedule a call. If it success, then it gets out, and then that's basically the entirety of start airdrop. And then we have execute airdrop that gets triggered every time the smart contract wakes itself up. And then we're checking the random recipient. Again, we're using the random number generator again to get a random person from the recipient. And then we are minting the amount that we have. And then we're emitting an event. And then we're checking max drops if it's still within our parameter that we set. And then next thing that it does is it mints it, right, to whoever the random recipient. And then you see here the last thing that it does, it calls the schedule with capacity check again. And then it finds the available second, and then it schedules. The whole thing repeats again and again and again, forever and ever and ever. That's basically the gist of this. All right, let's go ahead and try to deploy this. So I'm just going to copy paste the command here so it's just easier. Feel free to look at one thing that you want to do is you do have to set your Hedera RPC URL, your testnet, mainnet, and then private key. I already have my environment variable created, but okay, we're going to deploy this contract. All right, compiling. So what we're doing is we're sending 10 HBAR, either 10 HBAR, to our contract because it needs to have some HBAR to be able to call the future transactions. And then we're basically creating our token, workshop token, WKSP 0, blah, blah, blah. All right, that was done. So let's go ahead and check it out. So this is our contract that we created. Again, let me go back to, there it is. All right, so we created our contract. Now we're gonna use this in a little bit, but I'm going to save this contract address, deploy to this. All right, deployed. And then remember our register for airdrop. Before I do that, let me just verify this contract quickly. I already have the metadata file, but again, this repository also have this really cool script that you can use to generate a metadata.json file that you can feed in to your hashcan. So I'm going to verify this. Blah, blah, metadata. And it's just a way to automatically verify. Again, it's a simple script that I created. It should totally work to verify. So I just want to verify it so we can see everything that's going on here. So, okay, the contract got created. No events yet. Ownership transfer. Okay, that's fine. Let's go over here. All right, moving on. We're going to register ourselves. So we can call this cast through Foundry. All we're doing is we are calling register for airdrop function on our contract. And that's all we're doing. Again, you can also do this on Hashcan, and I'll show you in a little bit. So I'm going to register a second recipient with a second private key. But let me hop on over to this one. So let me copy paste this. Charlene, if you can share that. Also, I will share the GitHub link here. All right, so the GitHub link and the contract should be coming along. So feel free to go to the Hashcan contract link. All right, so guys, I want everyone who's out there to call this register for airdrop function. Currently, we have 2 recipients, but let's try to get more recipients here. So all you gotta do is call this register for airdrop function. I'm going to use my another account. Okay, account 3 is good. So all you gotta do is call register for airdrop using your MetaMask account. Okay, sometimes it didn't work for me, but it should work for you, I think. Let me see. Oh, I'm not connected. Okay. feel free to register yourself. If not, it's fine. I will just start the process. Getting in there, but you guys should be able to register. If not, we'll just play around with these two recipients here. So we have two recipients. We're just gonna have this random airdrop function getting executed. All right. I'll wait a little bit, and then I'm going to call. Let me go back over to my VS Code. All right, we registered the second participant. Now, there's a lot of cool things you can do using Foundry. You can directly call these functions. We also have get recipient function that we didn't go over, by the way, which you can totally look what it does. It basically gets the current recipients that's on our that's registered. So you can see here, okay, we got two recipients still. Well, I'm just going to start the airdrop so we can see this in action. All right, so what this is doing is it's calling start airdrop with these. We're going to mint these many tokens every 30 seconds. What is this? Start airdrop. Let me see what's the third. Start airdrop. Oh, max drops. That's how many airdrops that we want to do. So, I have 10, but let me just do. Let me just do 3 airdrops for now. And then hello from the future, blah, blah, blah. All right, so we're gonna start this airdrop and we're gonna see this in action after it gets executed. All right, let's check it out on our calls. All right, this is the function that I just called. We can deduct it. We just called start airdrop. If we look at the trace, okay, everything is good. Start airdrop, 30 seconds. Let's see what happens in 30 seconds. Hopefully that 30 seconds goes pretty quickly here. Let's see. It should be coming up pretty soon here. So, oh, there it is. You see, I did not call this function, but the network itself called this. And we'll see here what it did. It called execute airdrop. Perfect. And then what did it do? It used the contract to call the contract, the function execute airdrop. And then it passed in a whole bunch of parameters. And then let's see our AB. There it is, another call. All right. Nice. Well, and this will just keep on going, guys. So I have I think 10 H bar. Let's see, 7 H bar. You see every time. Actually, let's check out how much it's costing us. So I said 2 million, but we're only spending 1 million, so 1.5. So that's the only thing that you have to pay for. And then charged fee is 1.31 H bar. Not bad. Every time, every airdrop is taking 1.31 H bar from our contract. I'm going to let this run, and we'll come back in a little bit, see what happens whenever we run out of H bar on our contract. All right, let's see. You watch the hash scan. Let's see. All right. Okay. I set it to 30 seconds, so it's just gonna. Oh, I set it to 3 times. Let me just do it so that I just set more. I'm going to stop. So there's also a way to check. Oh, let's check the status here. That's pretty cool. So 1, whatever, zeros, tokens, 30 seconds, 3 recipients, I think, blah, blah, blah. And then there is a way to, I think there was a question here I quickly saw, but we do have a function called stop airdrop that would have, if you had this going on to infinity and beyond, then you could actually call this to stop the airdrop. So I could have totally called this function to stop it. So let me just do stop the contract. And then what I'll do, we'll see in a little bit. All right. And then we'll see calls. All right, we stopped it. You see, this is my on here. This is my account. I call the contract to stop it. Now, let's see. Now we're going to start the airdrop again, but this time I will do forever and ever. So let's do 100. I mean, we're not gonna even reach 5, the next 5, I think. Just to make it easier, I'm going to do, instead of 30 seconds, I'm gonna do 15 seconds. And then I'm going to change the message here. Good luck with your token. All right. So let's check out the events while that's happening. So we know that we have a couple of events here. So the slot found, this is our the find available second function that was using the random number generator exponential backup to get the next available slot, and then if it finds it emits the event slot found. Desired time was this, actual time was which means whatever time we set, we were actually able to find the empty slot. So that's why these are the same. But in your case, it may be something different. The desired time and actual time. So we're gonna see here. All right. Let's see. Another airdrop is happening. Let's see how many HBAR we have left. 3 HBAR. So we should have enough for 2 more. Let's see how many recipients we have. We still have 2 recipients. That's okay. Okay. We got 4 of these calls. Should happen every 15 seconds now. 4853, 4906. I would say don't go less than 15 seconds, because sometimes it may just fail. Just to be safe, 15 seconds, I've found that it seems to work pretty nicely. Again, but you can have 15 seconds to, I don't know, 62 days. That's an insane interval. Oh, there you go. And it kept on going, kept on airdropping. Just to see whether we did get our like how much balance we got as an airdrop. Let's check our balance. Oh, I do not get any. Let's check this one. Balance. Okay. So we have, let's check it out. So we have our HBAR 0.7. We saw that earlier it took 1.3 HBAR to airdrop. And then now we're back to 0.7, and that's why it canceled, right? So we see here, it actually reverted with insufficient pair balance. And we see here that when the contract runs out of HBAR, it basically stops. And so I have to restart the loop again. It looks like none of my accounts, I guess I didn't register my accounts there. That's why I didn't get the airdrop, but you get the point, right? So here we see all the events that are transfer to, okay, value. Okay, our A58 got minted this many token. There you go. And then we can check out more events. Transfer, okay. A58, let's see more. A58, it looks like, oh, 65C. Okay, that also got some tokens. All right, so let's go back to our slide. Oh, there it is. All right. And then let's end this on a high note. We saw this. Okay. So we saw all the events. Everything is working. Now, what can you build? Am I on the right slide? 21. Okay. So, before I get into, where is it? Yeah, before I get into the practical use cases, I just want to talk a little bit about what we did, right? We used exactly 2 of the Hedera schedule service functions that were available, right? 2 out of 10. We have the schedule airdrop and then the has schedule capacity or something like that. But there's also some other functions that, feel free to check it out on the system contract repository. But, there's a function called schedule with payer or something similar. What it lets you do is it lets you schedule a call where a different account pays the gas, right? Think about what that means for UX. Company could sponsor all the gas costs for their users, schedule operations. I think that's a pretty cool capability. There are some other things that we didn't go over, again, because I wanted to keep everything simple here. But there's other functions like sign schedule. What's the other one? There's delete schedule. You can delete your schedule, and that's what happened when we called our stop airdrop function. And then there's execute call on payer signature. That's a mouthful. But again, feel free to check it out. There's a lot of functions that are available on the Hedera schedule service precompiled. All right, what can you build? Let's talk about some of the things that you can build, right? So the self-scheduling pattern that we talked about is basically, you can think of it as a skeleton for almost all of them. So let me give you some concrete ideas that you can use on your hackathon, on your future projects, on your production projects in the future, whatever it is. One thing that comes to my mind is recurring payments, I think, is the most obvious one. Because imagine a payroll contract that distributes salaries every 2 weeks. What you can do is, from our contract, you can replace the random recipient with a deterministic employee list, and then replace the mint function with a transfer. And then the scheduling code basically stays identical. You could literally reuse most of the code that we had here. There's no HR person clicking pay everyone. The contract would do it itself on time every single time. And that's a really cool capability, the kind of use cases that it enables. And there's another one, token vesting, right? It's a natural fit, I think. Locked tokens, you can release those locked tokens to team members on a schedule. Right? There's no manual claims. Hey, can you unlock my tokens, messages that you have to send. The contract would release them automatically at each interval, right? You can have a cliff period with a simple check, and then so on and so forth. And then the big one is obviously auto rebalancing DeFi vaults. So we could also have scheduled governance deadlines. And then another use case that I can think about is maybe some kind of turn-based game mechanics that advances automatically. There's a lot of things, right? The gist is you can now build a DAO, a true DAO, decentralized autonomous organization that actually runs itself, rather than the DAO that's just 3 guys in a Discord channel pretending to be a protocol. That's the kind of capability that something like Hedera Schedule Service enables. All right, your competitive advantage. What you built is something your competitors on something like Ethereum. It's very hard to replicate because this is something enabled at the protocol level, right? And it's a really powerful feature. If there's one thing that you take away from today's workshop, it's that, hey, Hedera has these amazing native functionality that is enabled at our EVM level, which is just not possible on many other EVM chains. And you can utilize that feature directly in your smart contracts in a lot of interesting use cases. And right now, most Solidity developers don't even know this capability exists on Hedera, right? So it's a fundamentally different architecture, but if you can use it in a really interesting, creative way, you can really go the extra mile and build a lot of cool things. And that's my workshop. So thank you, everyone. I think that's the end of the workshop, but I'll take on any questions that people may have. I think you're on mute, Charlene.
Oh no, I am in mute. Shocks. Okay, let me repeat once again. Thank you so much, Kiran, for an insightful session, and thank you for making the concept of deploying smart contracts with native on-chain automation engaging, clear, and easy to understand. I don't really know how many viewers do we have. Louis, maybe you can feed us some numbers. But what I can see organically on YouTube, this is one of the highest I can see so far from Apex. We have 114 viewers. So I guess they love you, correct? What a great session, really. Very great session. Now I'll proceed to the live Q&A session. We have questions that we received actually prior to this. So apart from what will be asked on the live chat, if there's any, I'll also be sharing the question here on chat. These questions actually are more into DeFi and tokenization. So hopefully it's okay for you to address this as well, even if it's not particularly for EVM.
Sure. What's the question?
Let me just paste it here online. Here we go. Hey, hold on. I want to build a private token transfer in Hedera. Where can I find a tool for it?
So yeah, this is a really good question. And currently, there's no easy way to do it, at least on Hedera. But we are looking every day. We're doing a lot of research and development into how we can have private token transfer functionality, whether it be at the EVM level or at the native layer. Again, there's a lot of projects that have ventured into this territory, a lot of new projects that are really interested in private token, shielded token transfers, things like that. It's definitely something I would keep an eye on in the future. But as far as like the current status goes, it's you would have to build yourself. Again, you can totally do it, right? Because EVM, you can do anything on the EVM side. But as far as like offering that native out of the box, I would say just keep an eye out. There's a lot of research and development being done, and in the future we may have it. Again, I'm not exactly sure. If someone has an idea on a particular HIP that enables this private token transfer capability at the native layer, I'm all ears. Feel free to reach out to me or any other of my colleagues, so we can work with you, collaborate with you to have this feature on Hedera. But yeah, that's sorry, not the answer you're looking for, but definitely you can build it yourself. It's a little bit of a challenge, but not something that is offered right out of the box.
Thank you, Kiran. I have another question here. For tokenized future cash flows like recurring revenue streams, what primitives on Hedera best support programmable distribution and secondary composability without sacrificing deterministic settlement?
Yeah, this is a good one. So today we talked about the kind of capability that Hedera scheduled service provides, and you could totally have the use case that you're describing here, like a recurring revenue, something that you have a contract that you call and forget it, and then every so often you can have it so that it calls itself, and then it basically, you can even make it so that, hey, like after waking up, it's going to check out maybe the Oracle price, the token price, current price, using other decentralized exchanges. And then you can have a whole lot of other business logic. And then depending on that, then you can be like, oh, okay, then I'm going to either schedule another call because there's nothing to do right now, or based on whatever you find in that scheduled transaction, you can trigger some other contract to do something else, like some kind of payment or calling this another smart contract. Or you can even make it even complicated, where you may have a cron job that runs every 30 seconds, and then every 10 minutes, let's say, and then 10 minutes later you wake up, it calls the contract, it calls the logic, and then it says, okay, it may be a good idea the next time I want to call myself, I actually want to reduce that to, I don't know, in the next minute, because I want to keep an eye out on the price a minute from now. So you can have a lot of these interesting kind of logic. I think imagination is your only limit as far as that is concerned. And Solidity, as long as you can code it in Solidity, you can utilize the Hedera scheduled service however way that you want.
Wow. Okay, what a comprehensive answer. Thanks for that, Kiran. We have a live question that we just received. What if your scheduled transaction requires fetch and call parameters from an off-chain API? Is that possible?
So unfortunately, what you have to do, because we're talking about here is if everything is on chain, right? The contract, sorry, the network calls the smart contract to call itself. So whatever the smart contract, whatever access the smart contract has, you're bound to that. So if the smart contract that you have scheduled in the future is able to call, let's say Oracle price. Right? So in case of Oracle, I can give you a good example actually. So Oracle prices, sometimes people, providers, service providers, they basically take the price, the median price, whatever it is, and they put it on chain, the price, every so often, and then that needs to happen on a separate transaction, because that is something that you do using an off-chain API, right? Because you need to know the current price if you're getting the price from a centralized exchange. Let's say it's on chain. Once it's on chain, then your smart contract, it can utilize the scheduled transaction to call that every 30 seconds, every minute, to check the current price, and then use that price in whatever capacity that you want to then execute your logic. So in a way, indirect way you can, direct way, there's really no way to call an off-chain API from on-chain, so that's just not possible directly.
Thank you, Kiran. Okay, another question we have. Can we somehow abort future calls, like stop the scheduler in Solidity or something?
Absolutely, this is possible. I even showed a demo today. The schedule service has a precompiled stop schedule or delete schedule that will let you delete the schedule. So you can midway, if your contract is calling itself every 5 minutes, you don't want it to keep going on forever. Either you just take the HBAR away from the contract, or you basically stop the schedule by calling that precompile, which again, our contract that I demoed today also has that functionality. So feel free to check it out.
Thank you. Okay, this is the last one that we have, Kiran. What standards or patterns does Hedera recommend to make tokenized cash flows instruments interoperable across DeFi protocols rather than siloed inside a single app?
Yeah, this is a really good question. So as far as different ways that you could approach it, there is no correct way, or there is no standard way, right? And oftentimes, whenever and not just for this particular question, but for any other project, any other application that you develop, before you take it to production, in today's age, where you can like AI can detect a lot of vulnerabilities, and people actually use that to abuse the code that is incomplete or that hasn't been audited. Like, I would say auditing is the number one thing that, if it was not essential before, it is absolutely essential today, because even humans who audit the code, they may miss something, and you have to do your due diligence of auditing your contracts, whatever you deploy. And as far as interoperability across DeFi protocols, yeah, the interoperability is the future, right? And whether it's interoperability within the same network between different protocols, or from one chain to another, being able to call a smart contract on another chain from Hedera, or from on Hedera from another chain. Something like, there are a lot of capabilities available today, something like layer 0 Chainlink, CCIP. They do allow you to pass this message from one network to another, and it's available on Hedera. You can utilize those in your in your projects. But again, like I said, you always have to do your own due diligence. Don't, just because something is available, don't take their word for it. As in, even if they have gone through numerous security audit themselves, you still, the moment that you start writing Solidity code and it lives on chain, it's immutable, you have to also take the extra step of also auditing the code. And if you can, there's a lot of protocols available on Hedera today, and if it's not available on Hedera, something like bridging protocols are available. You can utilize other chains to do something, and back and forth. And there's a lot of tokens or messages being flown back and forth between different bridges. There's a lot that you can do. I would say, the first place is dive into the documentation, what those layer 0 CCIP they offer, and then try to integrate that into your protocol. Last but not least, definitely audit your code and see what you can do. There's everything that you can do on Ethereum or other EVM chains, you can do on Hedera. So it's just a matter of how you utilize the existing protocols, or you want to build your own. So it really depends what you want to do.
Great. Okay. Thank you so much for that. And that is actually our last question. So for anyone who still want to ask a question, I'm sending you the form link here. You can just put your questions there. I'll reach out to Kiran and reach back to you when he has an answer. Or of course, the best way to connect is to join Hedera's Discord. How? Just scan the QR code that you can see on your screen right now. Join the hackathon, and you will be concurrently offered to join the Hedera Discord. There is a button for that after a successful registration. And if you're also interested in participating in any of the main tracks of Hedera Apex Hackathon, once again, you can just scan the QR code on the screen, go straight to the hackathon page and join. Don't miss this, okay? Imagine it's 250,000 prize pool. All right, Kiran, would you want to say any closing remarks to our participants?
Yeah, I will just leave you with a note. Hedera scheduled service. Again, there's a lot of other native services that are soon going to be enabled on Hedera. Keep an eye out for all those hips that are soon being implemented. But things like these, right? These are native features of Hedera that Hedera hasn't had for a while. And then by extending it to our EVM, now all the Solidity, all the current smart contracts can utilize that native feature of Hedera. So it's a really best of both worlds, where you are using the Hedera as the best and the coolest features, but using smart contracts. So the kind of applications that you can build is only bound by your own imagination. So feel free to look it up, how you can utilize it in your own application, and go wild as far as building your own application, your crazy applications with it. So good luck.
Thank you. Okay, before we end this session, I'd like to invite you to join us on Monday, March 9, 10 a.m. Eastern Time in a dedicated Mentors Office Hours. This is the first time that we did it for the Hedera Trilogy or the whole Hedera's Hackathon since 2025. So please join us during the Mentors Office Hours. I'll be pasting the Zoom link here for your reference. Hold on. Okay, shared. Now during the mentors office hours, right? We have different private rooms per mentor, and the mentors that are available there are from Neuron, Hashgraph Online, Bonzo, AWS, Hiero, and of course our Hedera team. So please join that session. It will be a great time for you to double check your ideas and your submission before the 23rd of March, which is our final submission. We have 2 mentors office hours. One is on March 9, one is on March 12, but let's approach this slowly. So once it comes, we'll be announcing it. Just follow Hedera on their Discord, and you will not miss any announcement. And as a quick reminder, this week is a full of workshop. Obviously, you can see we have 3 workshops this week, and next week will be dedicated to help you get feedback from our partner mentors and Hedera mentors. So please head to Discord. Once again, you will not miss any announcement. My closing remark always would be, keep showing up, keep building, and here's to making big waves and the Hedera Apex Hackathon. So have a good one, everyone. Goodbye.